Okay, to start off here, we're going to take a look at just the basic concept of what you're going to be doing in this particular unit 3.5 where you're looking for zeros of polynomials and their multiplicity. And so this is a quick introduction video. So we're going to use our graphing calculator this time, and I'll show you how to plug this stuff in on the next video. But this time through, you're just going through and plugging these guys in, and so you got x to the fourth plus 6x cubed minus 11x squared, and you don't need to do this because I'm just demonstrating what's going on. Well, when I look at this guy, because he's a fourth degree function, his biggest exponent is 4, then that means that this guy should have 4 solutions. Now, those solutions could be real or they could be non-real, and that's what we're going to establish is how we can find those. We will use our TI graphing calculator to kind of get as many of those as we possibly can. So what we'll do is to get a visual of the graph, we can hit zoom and choose number 6 to start off. And what that does is it kind of, we know what we're seeing here. Like, I know that based upon hitting zoom 6, I get a window that is 10 by 10. So it says my x min is negative 10, my x max is positive 10, I'm going by ones. My y min is negative 10, my y max is positive 10, and I'm going by ones. So I go back to graph and I look at that, I know that this is negative 10 and this is positive 10, and those are going by ones right there on the x-axis. I know that this is negative 10 down here, and that's positive 10, and we're going by ones on the y-axis. So we can see, like right now, like kind of just guesstimating, it looks like I have an x-intercept at negative 1, 2, 3, 4, 5, 6, 7. I have one at negative 2. I have one at positive 1 and at positive 2. Positive 1, positive 2. So then what I can do is I can go to my table. And so my table, I get there by hitting the second key and then the graph key. And we've used this previously, so you should become familiar with it. So second and then graph, and you can see in blue there it says table, and that's where we're going. Unfortunately, I'm way down in the 45s, so I'm going to show you something else real quick. You'll notice right here above the window key it says table set. So remember, I may seem like I'm going very quickly through this, but my intentions is that if you miss something, you'd hit pause, rewind it a little bit, and then watch it through again, and kind of just keep doing that as needed. So I hit second, window, and I want my table to start at 0. I want my table to go by 1, so that literally means like the delta table means the change in the table going by 1s, and the other stuff will be auto. So now I go back to second, graph, and now I'm starting right at 0, so my starting value is 0, and I go to negative 7 and see what happens. So sure enough, at negative 7, I have y equals 0, and that means I have an x-intercept. I go to negative 2, I got y equals 0, that's an x-intercept. I go to positive 1, good, and positive 2, good. So without even having to do any algebra, I was able to find all of the solutions to this equation. And we're going to kind of be tying the technology in with this, but that's what we'll be doing throughout this particular section. The second equation, and if I take a weird look at the graph, you can see it crosses 1, 2, 3, 4. So the second equation, if I just go there real quick, turn this guy on, turn that guy off, do the same thing, go ahead and hit graph and kind of just see. So this is for the second equation. In this case here, I should have 3 solutions because the biggest exponent is 3. I can take a look at my graph. I can see, well, it looks like it crosses at negative 1, negative 2, negative 3, maybe negative 4, but not quite. And for sure, I can see it crosses at positive 2. So I can see x equals 2, and then I've got 2 points I'm not really sure about, and that's negative 4 and positive 4. Because it's not quite like right on it like the positive 2 is. So I go to my table, second, table, and I go to negative 4, and sure enough, like it doesn't exactly cross at negative 4. However, if you understand what you're looking at here, you can see that it actually does cross between negative 4 and negative 5, because my x values go from being positive, my y values go from being positive to negative. That means I crossed across the x-axis. I went across the x-axis. So, but that means it's a fraction. And the same thing down here. At positive 4, when I go to positive 5, you can see I went from negative numbers to positive numbers. So essentially what's happening here, if I had a rough sketch of this, or let's just take a look at the graph. Hit graph. So you can see that at negative 5, I'm down below. At positive 4, I'm up above. So that means I've somewhere between negative 4 and negative 5, I've crossed the x-axis. The same thing happens over here at positive 4 and positive 5. I went from negative y's to positive y's, passing through between negative 4 and negative 5. So what we're going to do is figure out a way to be able to find those values, and that's what we're about to introduce.